my dancer? Where's my dancer? This is a woman. This is a beautiful dancing woman. When you touch the stick, when you grab it, it's obviously a right-handed stick. We didn't have many left-handed people. But everything you sense from the airplane is right here.
We all left.
You can do virtually anything you want with this.
Louder.
I'm sorry, thank you. Better?
Yeah.
Hey, good. So I'm going to pass this around. Mike's in the back. This is sensitive stuff, so take care of it. But just grab the stick, and it fits your hand perfectly. Right? And when you fly the airplane, you can't tell an engineer, it's very difficult to tell an engineer that the stick is talking to you. It's impossible to tell an engineer that the stick is talking to you, but this stick is talking to you. It's giving you feedback on how the airplane's doing, and it's impossible, you can't quantify it. It's a pilot stuff, but it works. So we're going to pass this around, and I'll pass it around, just go around and touch it. John Manzi, I had the pleasure, of flying my last mission with him. John's going to do the back seat in just a second, I'll do the front seat. We have to be on time because as soon as we're done here, they're going to rip this place apart for the dinner tonight. So we're going to be on time. So basically, John's got a checklist, and he has an RSO checklist, I have a pilot's checklist. We're going to pass those checklists around to you, and you can gander through the 69 emergency procedures that you have to memorize. Otherwise, you don't pass the simulator check. And what we're going to do is John will go through the back seat, I'll go through the front seat. We should have time for some questions, okay? So let's get started, okay? BC Thomas will probably help us out tomorrow, but John and I will do the first one, and we really appreciate the museum getting us more than a 65-inch TV. I think we were running a 45-inch TV last time, and it was it was good, but it wasn't good. This one is really cool, and Don Campbell is going to make the presentation tonight on this screen. So there's a bird, an absolute marvel, gorgeous. Right behind the back seat is, whoops, the laser's not going to work on this. Right behind the back seat, there's the parachute door open. General plan, we'll do a little overview, the RSO position. And that's the goodies. Remember, the RSO is working his tail off. That's where the information is. We'll do the front seat. We'll go through it. It's a 360 visual. I can zoom in and zoom out. And if you have a question, raise your hand. But we want to be succinct because we want to finish on time. Okay, there's our cockpit. Look at that's a wonderful glass cockpit, isn't it? Beautiful glass cockpit. Okay, notice the digital systems in the cockpit. What is that? Anybody know? That's the Spruce Goose. That's at the Evergreen Museum. That's the Spruce Goose. Right behind that cockpit was a 350-gallon oil tank to feed the engines. They had a 350-gallon oil tank behind the engines, behind the cockpit. There he is. There he is. Hey, and you could be a command pilot. You could be a command pilot. Okay, and that's the B model. It's really cramped. The instructor position in the front. The laser doesn't work on the screen, but you can look at the guy in the front, and it's not that cramped. But the B model, which is the trainer, the guy in the back, it's really a cramped system. You don't want to fly there for more than 4 or 5 hours. It just gets untenable. There's the A model, and we're going to talk about the A model, and I'd be sitting in the front, where Tom McCleary's name is, and Blair Bozak in the back, and that's the window that John would be looking out of. That's what the front seat looks like. That's the front seat, and we're going to go through that at length, so don't think you're going to be cheated here, okay? And then we're going to go through the back seat, and this is where the real goodies are. There's another slide which I want to show you, more of a color slide. John, are you going to use this one or the other one? Are you going to use this one?
I think this one looks pretty good.
Okay, fine. Okay, so basically, that's what it looks like when you're operational. And there's so much information back there, and when we land, nobody wants to talk to the pilot, everybody wants to talk to who? How's the tape? Was the tape good? How was the weather? Was the ELIN good? Everybody wants to talk to John. And then I'll talk, that's the C model. It's really cramped when you're an instructor. And then we'll take a look at the front seat. So let's go back to the RSO position. What we're going to do is, John will show you his checklist. And we'll pass that around. And that's the checklist he uses in the airplane. And my checklist is just about the same size. So we can pass these guys around, you can take a gander at it, and John is going to go through the back seat from left to right, and you have a question, just raise your hand and we can do a question.
Okay, thanks Gary very much, and welcome to everybody. I missed the show of hands. For most folks in the seminar here, there we go. Okay, a lot of your work, great. If I repeat myself in any way, I sort of apologize. That checklist, by the way, is a standard item an air crew member takes with him or her when you get in an airplane. Why? It's the condensed version of your flight manual, and it has a lot of important information you routinely use, but a lot of it is also emergency kind of procedures, which you might have to use someday. And that checklist, if it looks sizable to you, it is. When I flew in F4s and F111s, the checklist is considerably smaller. But that gives you some idea of why we spent 5 to 6 months in the simulator before we ever got in the airplane. So we were all experienced crew members. Most had 12 to 1,500 hours or more flying in other airplanes. Very accomplished, very experienced crew members. And to have to watch the Blackbird fly every day while you're slugging it out in the simulator, learning it, required patience and professionalism to get through that, and everybody did, of course. That's part of why you were hired into the airplane. This arrangement's great. Thanks again to the Marchfield Museum to set this up, because we got a real airplane here. We got some pictures that help you see what you really can see looking over the rail there. But like an F4, the last airplane I flew before getting in this one, tandem seat arrangement, pilot in front, and an RSO in the back, which is what I did. That's the view of the rear cockpit. And one thing that is very different about this airplane than any other two-seater is that there's absolutely no connection between the two cockpits, at least from a crew member standpoint. In F4, you can kind of look around the pilot's head and sort of see out the front. Here, it's a wall. It's a wall of instruments. And we do have our 2 windows on the hatches, which was a relief. You got to look outside sometimes, and especially when you're down low, it's good to see Mother Earth down there. But you had this incredible crew coordination that you developed over the years that you flew in this airplane. And that was always true of two-seaters, F111, F4, and others. The pilot and the Wizzo in those cases had to be the same mind and very, very proficient in working together, minimizing communications between the 2 cockpits, because there's a lot going on. And you had to know his or her work, and then you had to be able to react to anything that came your way. Even more so on this airplane, you're totally dependent on an interphone to communicate with each other. Yet by the time we had done 5 months in the simulator together, we were in the exact same headspace, and unlike other airplanes, we really did fly together almost exclusively. And I think you can get some appreciation for that when you look at what the back seat did, which is navigation, first and foremost, to make sure you're staying on the black line doing your job, sensor operations, communications. Most of the mission communications are handled in the back seat, so any of the radio work is normally kind of back seat. And then finally being a kind of a co-pilot, safety flight observer, that sort of thing. And if you were in the seminar a few minutes ago, there were several of these airplanes lost, but most of them were in the early days of the program. And one of the lessons they learned early, after losing a couple of airplanes, was that they're not taking full advantage of the person in the back seat here as a safety observer. And there was getting no flight performance information in the back seat. No ADI, no airspeed indicator. And that might have saved a couple of airplanes. Because at least one instance I know of, the pilot became disoriented, the backseater couldn't help him out because there was nothing to look at. It was nighttime. So I'll kind of walk around the cockpit here, and I'll do it from an RSO's point of view. So I mentioned navigation. Well, there's
and John, what I'll do is I'll move the cursor.
Okay.
I'll move the cursor so you can get an understanding of where we're going.
Okay. Let's talk about the right-hand side forward part of the console here where the ANS is. So the Astro navigation system was the brains of the airplane. It kept track of where you were, It also provided commands to sensors and also to the navigation and autopilot system in the airplane. An incredibly integrated piece of equipment and extremely accurate, which as a navigator I'm always happy when my equipment keeps us out of trouble and keeps us going where we're supposed to go. That unit sat right behind the rear cockpit here, about here. Pretty massive thing. It was a big computer with gyroscopes, and on top of it sat this after-tracker, which is a little telescope, looking out through the top of the airplane and tracking stars. And when I learned to be a navigator, I had to do that manually with a sextant, and I had to draw lines on a chart and so forth. All that was programmed through this computer. And the mechanics and the optics were so well defined and understood that we had a plus or minus 300 feet track accuracy flying along. And for that day, in the 1960s, that was pretty incredible. Today we take GPS for granted, plus or minus 25 feet and so forth. But to do that with a telescope that could see stars day or night and do the calculations and provide the corrections to the airplane was a fantastic piece of equipment. It was backed up by, I think it was over on the left-hand side. Later we had a commercial or a standard military inertial navigation system added as a backup to it. And in its own right, it was a pretty good piece of equipment. So didn't worry too much about getting lost. Again, as a navigator, that was always a good feeling. We did have an opportunity, if necessary, to provide some corrections to the navigational unit. And there were a couple of different ways we could do that. One, you could do it with taking advantage of the radar system. You could find a fixed point on the ground and update it. But there was also a way to do it visually. And at the very top of the forward part of the cockpit is a view sight. And originally, and in this airplane, if you have to look at it, it's actually a piece of glass that will allow you to look down through the bottom of the airplane. And through a series of mirrors and so forth, you were looking straight ahead and down below the aircraft. There were a couple of cursors on there where you could line it up over a mountain peak or a crossroads or something and decide that's where you were at that point in time and send a signal to the computer and give it an update. Very rarely did we have to do it. As I said, the integrated system was that good for us. A couple of steps below that, this kind of funny looking, one more down, Jerry, the map display there. Again, today it almost sounds like comical, but we actually had a film strip that projected an image up in front of us, a color image of the ground we were flying over. We call it a moving map display. And it was a way to, without having to hold something in your hand, keep track of where you were over the ground. And it was pictures of a map basically with your course on it. And it just kind of followed, it was driven at a speed that we mapped to the airplane position of the ground. And it was pretty handy, but today I would never tell a story to my sons. They would laugh me off and say, well, you know what I can do on my phone today. But it kept you oriented. And meanwhile, remember the division. The pilot in the front is so consumed, as Jerry will show you, about keeping the airplane performing right and keeping it safe. You're flying Mach 3, very near the edge of the envelope, operating envelope of this airplane. You have to devote your attention to that. And consequently, unlike the F4 or the F-111, where there was a lot of overlapping duties, we both kept track of where we were and so forth. The pilot really shifted all our responsibility to the back seat, which in this case made perfect sense. We needed that much sharper division of duties to cover all the bases. Because when things went wrong in this airplane, they went wrong in a hurry. Whether it's how well the airplane was flying or where it was flying. And each of us had to be on top of that at all times. While highly automated, as I said, there were manual controls to the cameras we would operate, for example. It's in the very back, right on the lower side there was, I could manually control what the camera was doing if necessary. But again, the after-nurse nav system was integrated with the cameras. And it was actually, some of these cameras, like that were mounted here on the bottom right and left of the airplane, were framing cameras. They would basically move around and take a snapshot here and there, which was different than the camera we carried in the nose, which was a scanning horizon type camera. some missions we were doing both. But the framing cameras are extremely accurate, and they would be commanded to, at certain points along the track, aim the lens in different directions and take a snapshot. And you get these very high-resolution photographs, scores of miles off the track. So we got different kinds of looks at targets that way. I could manually do that. I actually had part of my folio I had with me in the airplane would tell me when I should point things here and there. But thankfully, I never really had to do that because the airplane was moving fast, and if you got it wrong, you're going to miss the shot. So again, the reliability of the airplane was exceptional. Okay. So communications, we had a couple different radios here on the left side. First of all, when we were flying in what's known as positive controlled airspace, basically up to about 60,000 feet, we were under control of FAA or the foreign controlling agencies where we were. We would have a code we'd send out to the FAA. You might have seen that in movies where they show you a radar screen and there's a blip on there with a number identifying who you were. That's done by a modem capability in the airplane. All our planes have that for the most part. So I would control that. I had the radios. I would talk to air traffic control. But once you got out, if you're on an operational mission, as Jerry said previously, you don't talk to anybody. You just you got arrangements worked out where we didn't have to make any radio calls. But if we're doing a training mission, like we used to do up the road here at the Air Force Base of Sacramento, you would act like any other airline. The difference would happen when you went above 60,000 feet. You were out of what's called positive control airspace. You're basically like a little bug smasher flying around low level on just a sightseeing tour. We had similar situation up there. We didn't really have to talk to the FAA, but we did keep them informed. And that kept them aware of where we were, who we were, and if we had to come down unexpectedly, they would anticipate what we were going to do. Okay, the other, I didn't mention it, but we're a military aircraft performing reconnaissance missions. Like any other military aircraft, we have to be able to protect ourselves to the extent that we can. While we didn't carry any weapons on the SR-71, strictly a reconnaissance airplane, we did have some electronic defensive measures. Jerry's kind of pointing out where the control panel is for that. This is true in any fighter aircraft and some heavy aircraft too. You have the means to detect radars are tracking you. You certainly have alerting systems to tell you when someone's getting ready to fire at you or a missile is tracking your way. And so we could use those kinds of measures to help protect the airplane. Our best defense is speed and altitude. If everybody understands that. We were a very difficult solution to target. You're flying at the speed of a 30-06 bullet, 3,600 feet per second, a mile every 2 seconds. Whatever analogy helps you understand how fast this airplane is going. That's really hard to target. And I've gone against, on a mission, we did a training mission against some fairly advanced fighters, and they knew where we were coming from, they knew what track we were on, and for their practice, they tried to intercept us and shoot at us. And generally, to catch this airplane with a missile, you got to be kind of approaching like this. If you're behind the airplane, chances of getting you not so good. So it'll run out of fuel and or ability to maneuver where it gets to. So we had a few different varieties of electronic countermeasures on board. And we did use them. Our mission was to get in as close as we could on people's borders without violating them. As I said a minute ago, if you've never been lost like you've been lost at Mach 3, if your navigation system breaks down, you're on a little bit of a course error, you're going to be over some of these airspace you shouldn't be in. So this would help us, just deter anybody from trying to track on us and do anything more than just watch us go by. All right, Terry, can you point to the colored lights on the left side, right there? Yeah, you can't tell from this, but I mentioned before how we were separated. I mean, physically separated from each other. One of those lights says pilot ejected. That's a good question. The question was could you eject at any speed, essentially? And the answer is yes, and it had happened. People had ejected at Mach 3. Just remember, you're in a very thin atmosphere up there. Dynamic forces on you coming out of the airplane are not like when you're low level doing supersonic speed, for example. So very survivable. We had the pressure suit. We had the souped-up ejection seat, similar to what we have the F4, more redundancies and more power to get you out. So none of us had any concerns about getting out. But that light's kind of funny. If people see that and say, well, isn't it obvious that the pilot ejects on you? Well, maybe not. Again, I can see out the sides, but that's one of the lights there. It helps crew coordination in emergency. You never wanted a pilot to beat you out of the airplane. You wanted to be on the same time. Yeah. But by the way, we did lose an airplane. Robbie Butterfield mentioned after 17 years of not losing an airplane, we lost one very near the end of the program, and it was unavoidable. Unfortunately, they had lost a hydraulic system. They were trying to recover into the Philippines and didn't quite make it. The other hydraulic system failed on them, and the airplane became uncontrollable. And that's the fate no one ever wanted to face in this airplane, to lose the thing. It was priceless and would never be replaced. So, but ironically, as the airplane was beginning to gyrate around and they were experiencing the G-forces, they were trying to get out of the airplane, and the pilot did beat the RSO out of the airplane. And he's the only RSO on record that has solo time in Mr. 71. Yeah, didn't want to be under those circumstances, but there it was. So that's it. We were Jack Manzi, and I'll answer your questions for a second. The reason I love this kind of flying was because the diversity of responsibilities and the extreme levels of crew coordination you can develop in this airplane. There's nothing as gratifying to know that you're both pushing an airplane out to this incredible level of performance, very near its limits, and you can do this routinely over and over again. And the speed, people often ask me, what's the speed and altitude? How do you know you're high? What's the altitude? Flying around the western United States like we did, you can see the same cities you see from an airliner, but they seem a lot smaller. I overflew an airliner one time, and so we kind of went over it. Now we're doing about 3 times the speed of the airliner, so he came into view through my viewfinder, and I said, oh, look at that, an airliner. And what struck me about it was, as we're flying it, I said, that looks about like when you're standing on the ground looking at an airliner cruising above, which when you do the numbers, that's about right. When you're on the ground, you're looking at an airplane about 30-some thousand feet away from you. And when you're in the SR at cruise altitude, you're looking down at an airplane about 30-some thousand feet away from you. So those kind of things, and flying from California to England in a little over 4 hours, really got my attention to it. And, took off one night out of Rio, and a couple hours later, we're on the other side of the country, getting fuel near Canada, and then we're hopping over to England in time for breakfast. That's good. So, the best adjective I ever heard of this airplane was it's a magnificent airplane. In terms of what the engineers did to get it to work, support crew to keep it running and reliable, and then working with just fantastic, in my case, pilots and vice versa, who are highly experienced, highly motivated, and some of the coolest cucumbers I ever flew with. So, Jerry, you ready to shift to the front seat? Yep.
Never. I wanted to know, was the Never-1 ever shot down?
No. The SR-71 was never shot down. The only ones that were lost were due to accidents or various reasons.
Thank you. Yeah. So the question is, the picture showed somebody in the simulator, and they were kind of way down there. And yes, you could move your seat down that low if you wanted to. And on a mission, you really need to be looking outside. So if you want to go down lower, just focus on the instruments, that's what we did. But you're in the pattern, being a safety observer, you wanted to be up higher so you can see out the windows and look for traffic of what you would see. So we'd always think when we're low, you wanted to watch out for traffic. Only ever saw one thing up high. We were turning one day on a training mission, I think it was, and I glanced out my left window looking up, and here was this silver thing that went by. And it went by like that, of course. Of course, you instinctively duck, which makes no sense at all. And well, we figured out it was probably a weather balloon, because we almost never saw anything at or above our altitude. So yeah, so being down low was one of the options for staying focused on those systems.
Okay, so what I'm going to do is we can do a complete visual here, and I can move this around. I can zoom in and zoom out. And what we'll do quickly is we're going to go from the left side all the way around to the right side. And while I'm doing this, John can interact in what he's doing in the back seat. And what I can't overemphasize is that when you're behind the tanker at night, it's always nice to have a calming voice telling you you're okay. Because if you look at some of the refueling tracks in the Pacific, they're 30-degree turns, there's no moon, the weather is terrible, the tanker rolls out, it's looked like Star Wars in front of you. And as they roll into a turn, you know you're in a 60-degree back turn. And the back seater is just sitting there saying, you're doing great, great hookup, doing good. 20,000 pounds of gas left, 10 seconds to disconnect, and you press the button, you go, thank you, Lord, I got another 80,000 pounds of gas. But John is right, the communication was so important, or the lack thereof, because you knew exactly what they were thinking. You knew exactly what each other was thinking. So let's do this. What we're going to do is we're going to, let me zoom out just a second, and there's obviously the cockpit. The resolution is not great, but let me move over here, and I'll start from, and then I'll zoom in. Okay, there's the seat. And there's the side. If you look at the upper left, that's the canopy rail. So here's all the circuit breakers. Here's all the circuit breakers. Here's all my radios, and I've got a VHF radio in the front, a VHF, UHF. John has a UHF, HF. We got radios all over the place, but basically, the guy in the back seat is doing most of the communication. Once we get in the traffic pattern, I kind of take over, but I'm just busy. I'm busy with keeping the pointy end forward and just checking things. It's the analyzation, from the time you jump into the airplane until the time you leave the airplane, you're going like this. Click, 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 click. You're looking, you're analyzing. And this is the goal. Never get 400 miles less than where the airplane is. When I'm in the front seat, I'm not thinking that the RSO is not there, but I'm looking 400 miles ahead of the airplane. If something happens right now, I am not landing here. If something happens over San Francisco, I could be landing at Edwards Air Force Base, because it's going to take us 250 miles to come down. And it doesn't matter what it is, it's going to take us about 200 miles to get from 80,000 feet down to 25,000 feet. So you have to kind of get yourself not get yourself into a box. You're looking 300 to 400 miles ahead of the airplane. And that's my job. And that's John's job too. So here we are, let's kind of zoom in, and there's the radios. We have radios, here's all the lights. There are the throttles, the two throttles. And these two lights, this is kind of the inlet system. And these four switches are kind of innocuous. It's one of the few airplanes you can do maintenance on the engines. I can do minor maintenance on the engines in flight. I can up trim and down trim the engines. I can adjust the engine's temperature and some of the RPM. And then these two innocuous switches in the back really control a supersonic set of doors where you can manually manage the doors. And really it depends on how efficiently you want to fly the airplane. So they seem so innocuous, but they're totally integrated into the supersonic performance of this is not an engine here, this is an inlet. 20 feet behind here, the engine starts. So this is the entire inlet system, which is compressing the air. It's taking 0.4 air, 0.4 psi air at 85,000 feet, and it's compressing the air to 15 to 16 psi, and it's also slowing the air down to Mach 0.5. The air has to go through the front of the engine at at Mach 0.5. Every engine does the same thing. So it's a big speed brake, basically. And what happens at the back? We're blowing it out the rear end at Mach 3.2. And it's never been duplicated. It's still state of the art. So here we go. There are the throttles. Let me kind of zoom out a little bit here. Oops, kind of go the wrong way, and I'll move over. And here's our environmental area. Right here. Right there. There's our oxygen, our cabin pressure. We fly at 26,000 feet. So we're breathing 100% oxygen. If John flies an 11-hour mission, for 10 and a half hours, he's breathing 100% oxygen. And breathing 100% oxygen, if you decompress, you'll be at 35,000 feet. If you breathe 100% oxygen and the suit inflates, if you decompress, the suit will keep you at 35,000 feet, and breathing 100% oxygen will keep you alive. That's what the suit is for, to keep you alive. So we have an environmental system, landing gear, lights, all our cabin temperature switches. If you look at this right here, it's called bay temperature. The front of the airplane from here forward is called the chime. All the instruments are in this modified chime on the side of the airplane. We want to keep that cool to below 140 degrees. The air conditioning system can cool. The air conditioning system in this airplane weighs about 600 pounds. It can cool 20 homes. It's taking 1,300 degree air from both external and internal from the engine. It's cooling the air down to minus 40 degrees Fahrenheit. And we're blowing almost 100 cubic feet per second into the plane. Why? The surface temperature is 500. We want to keep the innards below 140 degrees. And if we lose an air pack, if we lose one of the air conditioning packs, what do we have to do? We can't stay at speed. We're coming down because we're going to burn the place up. We're just going to burn the place up. So this is all our cabin pressure, heat. We have face heat, landing gear. We have our bay temperatures, and that's our indication of the bay temperatures. There's the drag chute. When we land, there's a 28-foot drag chute that comes out, and it's really a kick. I mean, it stops you. We can stop the airplane at 4,500 feet. Just stop it. It's really well done. This is a very important gauge. Let me just go up here if I can here. There you go. I'll zoom out slowly. I don't want to throw you up here. Whoops. Let me zoom out. There's the front plate. That's 620 degrees. There's the standby attitude indicator. There's the attitude indicator. We have steering bars in the front. And when John is navigating, this center bar is a track bar. Let me just zoom in for you there. This center bar here is a track bar. That stays right on. It tells me if I'm on track, plus or minus 300 feet. So if I see that bar wavering, I would ask John what was going on. The horizontal bar is a pitch bar, and we can fly the pitch. But remember, every 1 degree pitch change at Mach 3 is 3,000 feet per minute. So we're doing 20ths of a degree. We're doing incremental pitch changes. And the plane basically cruise climbs. What I'm trying to say is that as the fuel goes down, as we burn fuel, the plane gets lighter, gets a little more efficient. So if we start at 75,000 feet, we cruise climb. We lose 4,000 pounds of gas. We're slowly climbing at about 200 feet a minute to 76,000 feet, then 77,000 feet. So if we have a mission where we're down to 20,000 pounds of gas, we may have started at 75, but we end up at 80. So we're just cruise climbing. Why? The plane is getting more efficient, it's burning less fuel, and if we have to save fuel, do we go slower or do we go faster? We go faster. We're more efficient at 3.2 than we are at Mach 2.8. Why? Because of this guy right here. It wants to compress air. It loves to compress air. It really loves it. I'm going to show you those. Okay, so there's the airspeed indicator. That's our temperature gauge. This is very important. We have a red mark there. Let me zoom in just a bit here if I can do that. And come up. And that mark, right, you see that 450 there? That mark is 427, but that's not Fahrenheit, ladies and gentlemen. That's centigrade. That's 800 degrees. That's not the exit temperature of the engine. That's the inlet temperature for the inlet. The engine is seeing 800 degrees at the face. Now what does it say about the air? Give me more. It just wants more. That's all it wants. Okay, this is what we call the only digital gauge. It's not a digital gauge. This is a triple display indicator which we use. We don't use this at speed. We use keys. Special term, it's not airspeed as you would know it. There's our altitude, and there's our Mach. So basically, we level off at Mach 3. This would read about 410. This would read 73,000 feet when we start our climb. And this would read Mach 3.00. It's not going to read Mach 3.01. It's not going to read Mach 2.99. You're not going to fly Mach 2.99 in the simulator. When we want Mach 3, what do we mean? Mach 3. When we want 2.8, we don't want 2.82, we want 2.8. And that's what you train for. You train to be the best instrument pilot in the world. At the end of this, you're the best tanker refueler, and you are absolutely the best instrument pilot in the world. Because we demand that. We do demand that. Okay, let me just move over a little bit here. There is one of the more... Oh, what do I see here? What do I see there?
Yeah.
I go, John, are you there? You there? Okay. This is one of the more important gauges. This is the compressor inlet pressure gauge. And you see that one right there? That's standard. Meaning when we get on the airplane, it's reading 15 psi. It drops when you start the engines. We can get up to 18 to 19 psi. That's how efficient the inlet is. And that's how the airplane flies Mach 3. It's very efficient. Here's our inlets. I would say these three gauges here, 1, 2, 3, 1, 2, 3, 4. 95% of the times the inlets are automatic. We can manage the inlets with our manual switches behind the throttle. But we can take the inlet, we can manage this, we can manage the spike, and we can manage the doors. We would rather not do that because we're not as efficient as the computer. You have to keep moving the switches. As you increase speed, you got to move the switch. Increase speed, you got to move the switch. But if we have to do it, and during training, we all fly manual engines. We all practice flying, going from 2.8 to 3.0 and higher. We all practice, and every once in a while you make a mistake, and you go the wrong way, and you know right away. You have a massive unstart, and you say, don't do that again. But you actually practice to use all these switches. And these are the gauges that tell you where the spike is, where the doors are, and there's our CG. We rarely see anything above 2 Gs. I don't think I've ever seen anything above 2 Gs. No. The highest G is the pitch out of the traffic pattern. So you can understand it. Longitudinally, we have 80,000 pounds of gas in this thing. You could break the back of the airplane very, very easily. So it's a very low G airplane, extremely low G airplane. Okay, we have our trim switches. These are our special restart switches. If I have to put one engine in restart, I can use a special switch. These are trim switches. When I was in the simulator doing my evaluation, I kept on trimming this way. And for those of you who fly, we have pitch trim, right? And we have aileron trim, correct? That's not what it works here. We have rudder trim. The aileron trim is separate. And when you look at the back, longitudinal stability of this airplane is critical. That's why it has such big rudders. We never want the pointy end forward to move someplace else. Once the pointy end moves someplace else, this airplane is non-recoverable. You have to keep it at 6 degrees angle of attack and keep the pointy end forward. Otherwise, it will just break its back. Okay, so let's kind of zoom out a little bit. And I will move over. I have to kind of be very sensitive here. There we go. Okay, there's our angle of attack gauge right up there. The plane flies at 6 degrees angle of attack.
Eject.
Eject. Here, I'll put it right there. The airplane flies at 6 degrees angle of attack. There's our ADI. There's our HSI. That tells me horizontally where I'm situated. And when this bar is vertical, that stick is dead center. What does it mean? I know The RSO is not going to say we're off track. We are right on track, plus or minus 300 feet. What year is it? It's 1964, and we're flying plus or minus 300 feet, looking at stars. Looking at, with an astro tracker, looking at stars. That's how, we call it R2, it looks like R2-D2. A big crane comes and puts R2-D2 pre-programmed in the airplane. It's a big, it has a, we were going to paint the big white sign around it. And the B-2, everybody remembers the B-2 bomber?
Right.
What's the backup system in the B-2? This astro tracker. And it's 45 years old. They've updated it. That's how good it is. That's how good it is. Okay, so we're coming down. Here's the stick. We have a few switches here. Here's our annunciator panel. This is a 48, 49 set annunciator set of lights. It gives us both warning, which is red, and caution, which is yellow. We can say low hydro, but all the caution and warning lights are here. Here are our computer switches. We have trim switches. Remember the map display that John showed you? I have a map display right here, and it truly is cut and paste. I mean, it's a cut, they're cutting the map out of maps, and they put it on a roller, and the map rolls by me, so I don't get confused. Is it turn 21 or turn 19? You can always look at the map, but it's kind of a weird, but it worked. I mean, it worked. So while I'm doing all this, there are times when I can talk to John, but when it comes to the take area, I don't say a word, because he doesn't want to be bothered. Meaning, he's really a busy man. He's really a busy man. Okay, we have a clock, standard. We have an altimeter, which we really don't use supersonically because it's not accurate. So when we get off the tanker and start excelling, we use the triple display indicator for basically our altitude, speed, and Mach. That's what we use. Okay, coming down, there's our vertical velocity indicator. Okay, and remember, a 1 degree pitch change at Mach 3 is what? 3,000 feet per minute. Incremental pitch changes. 20ths of degrees you're working with to fly the airplane. Okay, we have air refueling. Here's our air refueling switch. We have a keys, and you fly on airspeed. There's a difference between keys and airspeed, but keys means what's actually going over the wing. Here's an example. At Mach 3, this airspeed indicator will read about 520 knots. But at Mach 3, the keys indicator will read about 410. And it has to do with compressibility. We want to know what's actually going over the wing. We want to know the dynamics of the airplane and the dynamics of the keys because of the errors, because of the basic errors. So we're flying that. Okay, so we come over here. And we come over, oops, wrong way corridor. Oh, what's really cool? You see all the stuff right here? John, you got that back too, right? You got that stuff in there? And when you open up your visor sometimes, what happens with this one? At the Mach 3, if you have an airplane that just came out of a depot, this stuff starts to burn. So you open up your visor and you go, what's that? And that's some of the stuff actually that's been burnt. Remember, what's the front cockpit? 620 degrees. So some of that just burns, and you get this interesting smell when you open up your faceplate. You know the airplane's been heated up. Okay, over here we have our RPM gauges. We have our, these are blanked over, but these are 2 fire warning lights, which we don't have to see. I've seen one at Mach 3, we lost an engine. Here's our other digital gauges, but they're not digital, they're just counters. They're just little bean counters. They go click, 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 click. Here's our EGT gauges. These are all instruments for engines. We have RPM, fire warning, EGT, nozzle position, which really is the critical one, fuel flow, hydraulics, and oil pressure. And remember, this is so interesting. Remember what I said in the panel when you take off? Does anybody remember what the fuel flow was? 72,000 pounds per hour per engine. 2 minutes, in 2 minutes we get from sea level to 25,000 feet, and we've gone through 5,000 pounds of gas in 2 minutes. And we're burning 144,000 pounds per hour. At Mach 3.2, we're burning less than 40,000 pounds per hour. It's amazing. It's really amazing. Okay, so here are all our navigation. I can go, I have ANS, INS, and I tell John where I am, but basically I'm generally always for operations in the ANS, that's tied to the task tracker. Okay. Here's our navigation, here's our map display. All the engine instruments. Over here is fuel and electrics. There's our, let me zoom this in a little bit there, and move over. And you see what? You see a big 80 there? And remember, why do we deal in pounds and not gallons? Anybody think about that? Anybody? Why do we do it in pounds? You get 5 gallons of gas. Okay, pounds are density compensated, meaning the fuel, liquid, is a density issue compared to temperature. So all airplanes deal in pounds or kilograms. So we came back, we were coming back from Okinawa in December, coming through Alaska at cold day, and it was minus 87 outside for the tankers, and the tankers were orbiting. We got in 83,000 pounds of gas. Why? It was so cold. We got in again. I said, Matt, are we going to punch off? No, we're still going. There's 80,000 on the clicker, where we have 81,000 on the clicker. I said, there's got to be something wrong. And all of a sudden I thought, we punched off at just under 83,000. Why? The fuel was sitting up there in a tanker at minus 60 degrees, 70 degrees, and it just got cold soon. So pounds are density compensated for. Okay, so there's our, and I can go to tanks. Here's our center of gravity, which is absolutely critical. We have, the plane is CG limited. You don't want to get too off or too far forward. The plane manages its fuel just like the Concorde. The Concorde manages its fuel to keep the CG, or center of gravity, within limits. We do the same thing. And we can manually forward transfer and aft transfer. And what happened is that if you transfer, there's a little thump. And some RSLs will say, you always tell the RSO, you never not tell the RSO what you're doing in the front seat. You always inform them. That's the goal. Well, I was a student on my first flight, and we were there, Bill Keller, who was at Jack's backseat, that flew me. I turned onto the runway, and the CG was a little bit too far forward. So I take the aft transfer switch, and I hold the aft transfer switch, and you hear this thump. And I get this voice in the cockpit. Major Glasser, don't you ever do something in the front seat without telling me. I said, how the hell do you know that? I heard the thump. So basically, the trust between the front and the back is there are no secrets. You always keep everybody, if you're dumping, you always keep everybody totally informed, and you're totally into that. And if you don't do that in your simulator, you're not going to make it. People have failed. They could not communicate. They couldn't think 400 miles ahead of the airplane. But you had to succinctly communicate with your backseat. Not and, but, I think, kind of, you know. Straightforward communication is critical. That's critical. Okay, we have liquid nitrogen on board the airplane. We've got about, and we're going to have some time for Q&A. We have liquid nitrogen on board the airplane. Any thoughts? Any thoughts? Well, we carry about 150 liters of liquid nitrogen. Nope. That's a good answer. I haven't heard that in a long time. That's good thinking. Nitrogen. Okay, why doesn't the world blow up when you light a match? Come on. 78% coming in is what? Nitrogen. What's coming out? 78% nitrogen. How do we prevent the fuel tanks from blowing up when they're up about 400 degrees? What do? We convert the nitrogen into gas, and we pump all the fuel tanks with nitrogen. So if we lose nitrogen, we're limited to about 2.4 Mach, because we don't want to get the temperatures of the tanks so high. So we have 3 big doors, and as we fly, the liquid nitrogen is turned into gaseous nitrogen, and we pump it into the tanks to inert the tanks. Airliners sometimes, if you have airliners, they're going to try to do the same thing, to inert the tanks so they don't explode. Years ago, remember Flight 800 in Long Island?
Right.
Boost pump wire, boost pump started, vapor tank, and the whole plane just blew up. If it was inverted, it wouldn't have happened. So, let's, oh, there's my forward transfer switch. That's the switch I hit, and that was the thump. And Bill Keller said, don't you ever do that again. Don't you ever do that. That was my first flight in a solo airplane. I thought it would fail. Okay, let's come back out. Okay, there's the individual fuel tanks. Over here is the electrical system. We have two 40 kVA generators on the airplane. They're huge, absolutely huge. And they're tied to a drive system with the hydraulics. But we have AC buses, DC buses, AC, DC buses. And basically, I made a mistake. There are our two generator switches. These are just, let's say these are electrical switches. Well, it was my second training flight in the V model, and you start on external power. Anything you see here that's kind of strange, let me get this down here. Anything you see here, I'm going to come in, here we go. I'm going to come in and get it down. What do you see that's strange to the generator switches? On is down, emergency is up. So, I don't know if it was Buzz or, he says, and you go, the checklist says, external power going to be disconnected, generators are on. So what did Mr. G do? I turned the left generator to emergency. Oh, something, you saw a little mess. So we had to restart the whole thing because I had one generator powered in Eber. The emergencies are up and the ons are down. Why they did that, I don't have a clue. I don't have a clue. Okay, here's all the fuel. I can look at individual fuel lights. I have fuel dump. There's emergency fuel. Let me go back out here. I can select tanks. I can select tanks. Over here is our computer autopilot system. All my radios, and way back here, and I'll come back in a second. Way back here are circuit breakers, and what John said is correct. There's a couple of circuit breakers you have to know, and there's a couple of circuit breakers you can't get to. So there's a circuit breaker puller in the front seat, and it's back 2, down 1. So you're kind of going like this, trying to, and you look at the circuit breaker, and you can say, okay, that's back 2, down 3, and you're counting if you have to pull circuit breakers. We've all pulled and reset circuit breakers because of the thermal problems. But you have to move, you have to pull your helmet around to physically see those. Let's go back to the autopilot system. And basically, it's a wonderful autopilot system, but it's not a pitch autopilot system. You manually, there's no automatic pitch control. You're physically manually flying the pitch for the entire mission. And basically, if you can set it for about 1/3 of a degree, as you level off, every 4,000 to 5,000 pounds we burn, we're going to climb about 1,200 to 1,500 feet. And if you set that, it works perfectly. But what happens here? Sometimes the temperature's standard, sometimes the temperatures are hotter, sometimes the temperatures are colder. This airplane is incredibly temperature sensitive. As John knows, in the winter, going to Murmansk, it's like a rocket. It is an absolute rocket. In the summer, when it's plus 40, we have trouble getting up to Mach 3. We struggle to get up to Mach 3 because the inlet is incredibly temperature sensitive. So we look at the temperatures, and temperature and fuel, there have been times when we've tried to get to Murmansk, but we had to turn around. Why? We couldn't make the turn because the temperatures were so high. That's the autopilot. Coming back here, we have our radios, we have our circuit breakers, and let me come, whoops, we're on my cord again, sorry. I don't want to make you throw up, I know it's kind of strange. And let's zoom in, and let's go up. So while I'm doing this, anything I do something, any time I make a change, depending on how accurately you want to fly the airplane, but at Mach 2.8, we can shift the doors. But I don't want the back seater doing something while I'm shifting the doors. Because my first thing is, if it doesn't work, we're going to have an unstart. And I don't want him surprised. So I'll say, John or Mac, we're flying with us, say, okay, Mac, level at 2.8, resetting the doors down. And I'll switch the doors. So he is not doing something else and says, what the hell happened? So it's total communication. But there's the front seat. What do you notice? Is anything digital? Why isn't this a glass cockpit with all the good crap that why? Tell me why. Thermal, what's the worst thing for your computer? Put a match under your computer and see if it works. Analog works perfectly. Oh, you know, what's interesting? I'll go to Robbie and I'll say, he said, how's everything going? You know, we just had 2 refuelings, we had 3 sets, temperatures were a little hot, EGT gauge flexed a little bit, popped in all pressure circuit breakers, reset it, and it all worked. That's about it. And you go, what? We just flew 3 hot legs, we had a fluctuating EGT gauge, popped an oil pressure circuit breaker. How was the take? Oh, the take was great. That's how nobody climbed into this airplane afraid it was not going to work. Nobody. It was amazing. Ladies and gentlemen, look at a 5 looper, which you flew, right? Look at a 5 looper. You take off. And you flew out of 5 It's 90 degrees. The temperature's 90. The temperature's 90. Humidity's 85. The plane takes off. Goes through a tanker. It's minus 70. It excels. It gets up to 550. You do that 5 times with a cable-controlled airplane. And John, what were the write-ups? Go ahead, sir. Go ahead. I'm serious. What, after your Persian Gulf missions, talk to them. What were the write-ups?
Yeah, as I recall, and it was this airplane, by the way. I think we had little or nothing to complain about with the airplane on the
You
ground.
may have had a couple of minor things, you know.
Yeah, nothing memorable.
No, a burned out light bulb or something. I mean, don't you find that absolutely amazing? This is 40 years of technology, and we were in awe. Every time you get in the airplane, there was something new. I flew an FCF. The plane was going to go to Mildenhall, had an engine change. I flew with an RSO. He was from the Bronx. I was from Queens. Guess what? Separated by 2 million people. Nobody from the Bronx liked people from Queens, and nobody from Queens liked people from the Bronx. We only flew once together, and we saw 4 sunsets and 3 sunrises on one mission. And we didn't know it. We didn't know it until Joe in the backseat said, Jerry, there's another sunrise. I go, what are you talking about? I'm sitting there, we're writing down. He says, Jerry, this is the 3rd sunrise. I went, you got to be kidding me. And then we went through 4 sunsets. And the airplane just, what's wrong? Oh, we got a couple of burned out light bulbs, and, popped the circuit breaker, and all flew well. And I say, even the shuttle pilots don't see a sunrise in the west because the shuttle is concentrated. We saw, and John's seen sunrise. A sunrise in the west. Are you kidding me? And we saw 3 of them on one mission, and I was oblivious until my backseater said, Jerry, this is another sunrise. I went, holy crap, we're seeing another sunrise. That's how good the airplane was. Okay, we've got about 5 minutes. Any questions? We can answer questions for you, because what's going to happen, we have another, Jack Beth is going to do another presentation at 2:30. He has a good presentation. But if you have any questions, they're going to start. We'd like to have the checklist back, please, and my lady, you got it?
The sticks up there.
Okay, you need the checklist and the stick back, please.
Slide rule.
Sticks behind you, Jerry.
Oh, I'm sorry, here we go. The stick is here.
You got your
The
slide
checklist
rule.
is here, thank you. And what else?
Slide rule.
I've got the slide rule.
We're good, thank you.
Thank you. Okay, guys, this is valuable stuff to us. You can't use it. Okay, a couple of questions, and then we're going to start turning this place down. Go ahead, sir. And both to John and I, because he's a worker.
When you're refueling from a tanker, there must be times when the weather is not very good. What was that like?
The challenge, you get to be really good because you get up to about 76,000, and depending on the temperature, obviously, you have to take the left engine. You can only use the left engine in the afterburner. So we light the afterburner, and the plane kind of reaches forward, and you take the right engine back. So you're sitting there bouncing around, but you develop a confidence. The boomers, we know the boomers, we know the tankers, we know the crews, we know what to do, and they have total confidence in us that we're not going to run into them. Very few breakaways, but the refueling for some was a challenge, for some who were a little more experienced in air refueling. But this is a 140,000-pound airplane behind a KC-135. But I'd say about 70% of the time, you had one engine and above about 75, 77,000, you had one engine and afterburner, and at night, it is spectacular. You have to tell the boomer, especially a new boomer, you're lighting the afterburner, because it is a light show. I mean, in the clouds, it is a light show. Here comes the afterburner, and this big light goes up. So you tell new boomers, the afterburner is coming, the afterburner is coming. Everybody can do it. Go ahead, sir.
How many were made?
50,
How many are left?
Okay, 50. There were 18 A12s. There were 32 SR-71s. Of the 50 total airframes, there were 50 total airframes made. 20 were lost. The rest, 50, 20. The rest are in air shows. I mean, in air museums.
And how much did it cost?
About $3. I'll give you a hint. The program's annual budget at the end was about $400 million to $450 million. You could take 3 SR-71s for one B-2. A B-2 is $1.7 billion. Our entire program was less than $500 million, and we were flying a mission a day. Meaning every mission was about $1 million. We talk about tankers, where we were going, we were flying around the world. So, but our budget was a third of the B-2 airplane. Got that? Yes, sir.
This question's been bothering me since I was a kid, but where's the laboratory on this?
Wait a minute, you're still a kid.
Oh, thank you. But where's the laboratory on the plane? I mean, how do you take care of business, and what would happen if, let's say, you had a bout of, something, where you had it like, number 2?
John, take care of it.
So there was a kind of a tube device you wore and a collector bag if you needed to urinate, and that worked pretty well. You were at 11, you had the kind of problem you were thinking about, and one of my contemporaries did have that problem, and it was not pleasant. Because you're in a three-piece suit, basically. The main body of the suit, the helmet, the individual gloves that attach on these rims. Got a question over here. Over there.
Hi, first I need to give a shout out to Jerry from Steve Grzewniak.
Oh, thanks.
He said you were one of the best trainers he
Well, I
had.
appreciate that.
He's in Australia. I just talked to him
Thank
2
you
days
very
ago.
much. That's much appreciated.
I had a question about the TEB, the JP7 fuel, and basically distribution. My father was Bob Hall. We were in Milton Hall for 5 years. And I was really interested in, you have a plane that's stationed at pretty much 3 different bases that uses its own fuel. What was the distribution like that? How did they get the fuel to the bases? You know anything about that?
Mike, do you know anything about how did the fuel, like, okay, when, if you went to Diego Garcia, what were the tankers, tankers which were a ship?
By tanker.
It was by sea tanker.
Same thing with Okinawa,
So it was done by sea.
by sea,
Interesting.
and the States rail car.
Okay, wow. I didn't know that. I didn't know that.
And then TEB,
Oh, the TEB.
or was that the afterburner? Is that
Yeah,
correct?
yes,
Oh, for the engine as well?
the engine, like the engine and afterburner.
I was there when, for one time when they started up with the muscle cars, motors, the startup hangars and stuff. But the TEB, from what I understood, was like the afterburner, and it's controlled by the throttle,
Yes,
and you only had certain
16
So after
16
that-
lights per engine.
After that, you couldn't hit the afterburner.
Well, you could up-trim the engine and hopefully light the
Light it from the heat.
Yeah, you could light it from the heat. Okay, hey guys, we're about done here, but seriously, this is my instructor. I love it. Happiness is Mach 3 and getting a chance to do it more than once. My good buddy, I went to college with, John Waha, flew the space shuttle, and he said, I spent 7 years training to fly the space shuttle, and you're flying the SR-71 every week. I'm envious. And I said, well, I'd like to trade places with you just once. Happiness is that. Happiness is good instructors. Happiness is having DC Thomas, because I lost an engine in my first tour my first tour, we blew an engine turning into Korea, and it was really a bad situation. And if it wasn't for BC Thomas in the simulator, everything that he taught me in the simulator, I did, and we did it right the first time. And you know, you get to know your instructors and sometimes don't like them, but when crap happens, you really love your instructors. Okay, and basically, thanks a lot, guys. Thanks a lot. I appreciate it.